to naming covalent molecules. So we talked about drawing them in Lewis dot structures last time. Now let's give some of them names. So since these are covalents, we're sharing electrons, so no charges are involved anywhere. No positives or negatives. The most you can get is maybe a partial with a polar molecule, but that's it. None of the positive or negative nonsense we had with ionics. Excuse me. This means no parentheses anywhere. With ionic compounds, we had those bloody parentheses that caused everybody so much grief. Indicating the charge of variably charged transition metals, no parentheses under any circumstances here. Instead, we are going to be using prefixes to indicate the number of atoms present. So, for the first time, we actually get to indicate the number of atoms present. Ionics, all they told you was the charge. Now we actually have the number of atoms present. So these are the prefixes that we're going to be using in our naming of covalents. 1 is mono, 2 di, 3 tri, 4 tetra, and so on and so forth. So whenever we're going from formula to name, our first atom is going to use the whole element name plus whatever prefix we need. The second is going to use whatever prefix you need, and then the root of the element name plus that IDE suffix, similar to what you used in ionic naming. So let's start off over here on the left side. Let's start off with H2O, our buddy water. Everybody knows water, but let's talk about the chemical name for water. This first element here, the H, this is hydrogen. For our first element, we use the entire element name plus whatever prefix we might need. I have 2 hydrogens. If we look up at our chart, we find out that the prefix for 2 is di. So this is dihydrogen. Now on to our second. For our second element, we use the root element name plus the IDE. So this is oxygen. So this will be oxide. There is only one of them. If we scoot back up to the top, our prefix for 1 is mono. So monoxide, those O's kind of get squished. So water, his proper chemical name, is dihydrogen monoxide. Actually tells the number of atoms present. Notice I didn't do charges, I didn't calculate, no math, no nothing. Just prefixes and the number of atoms present. Let's try another one, CO2. You probably already know the name of this guy, but let's go through the paces anyway. Our first atom here, the C, is carbon. Forgot my R there. Carbon. Since there is only one carbon, you could write monocarbon, but that would be a little bit redundant. If there's only one atom in the front, we can forego the prefix. So carbon, here's my O again, oxide. In this case, there are 2. Remember from our previous problem that the prefix for 2 is di. So this is, as I'm sure you already knew, carbon dioxide. Let's try a few that are a little bit less familiar, perhaps. N2O6. First element uses the whole name, nitrogen. I have 2 of them. My prefix for 2 is dinitrogen. Now on to our O. Seems to be a favorite of mine today for some reason. Whoops. Oxide. But how many do I have? I have 6. If we look up here at our prefixes, 6 is hexa. So this is dinitrogen hexaoxide. Last one down here. B stands for boron. I have just one of them, so I can forego the prefix. My H, that is hydride. And I have 3 of them. And from our chart, we see that the prefix for 3 is tri. Let's try just a couple going the other way. From the name to, from the name to the formula, so let's try perhaps diphosphorus pentaoxide for starters. So, diphosphorus tells me my first element is a P. That is the symbol for phosphorus. Di tells me I have 2 of them. On to my second element. Oxide tells me it's an O. Penta tells me I have 5 of them. No parentheses, no math, no muss, no fuss. Ta-da, there she is. Let's see if I can come up with another one off the top of my head. We could do silicone tetrafluoride. So silicone, there is no prefix, so we assume there is but one. Si is the symbol. Tetrafluoride, fluoride tells me my symbol is an F. Tetra tells me there are 4 of them. SiF4. So the naming of covalents is considerably more straightforward than the naming of ionics. We have no charges, no parentheses. The prefix tells you how many atoms you have present. I hope that was fairly simple and straightforward for you. As always, if you have any questions, please let me know in some form or fashion so I can help out further. Take care.